Hi, I'm Benny D, and in this video we're going to look at the exact distribution of the sample proportion. Okay, so we're going to start off by looking at sampling distribution. Okay, this is really similar to probability distribution found using binomial distribution. Okay, so we're looking at here, we're going to have a table here. We're going to have our sample proportion, okay, p hat, okay, and they're going to be running across here. So our sample proportion could be like 1/4 or something like that, or 1 out of 4. Our sample proportion could be 2 out. Well, we'd start off with 0. Sorry, if we were say doing a sample of say 4 things, okay, then our sample proportion, okay, of getting a particular item out of that would have none. We'd have 1 out of 4 things, 2 out of 4 things, 3 out of 4 things, 4 out of 4 things. Okay, and then just the probability, okay, of getting that particular sample proportion. Okay, and we use capital P hat equals little p hat. So we say capital P hat is a random variable where p hat is our sample proportion. Okay, so our sample proportion would be anywhere from 0 out of how many things all the way up to say n out of n things. Okay, for small samples, we may be required to find p hat from a sample. So for example, we could be told that we've got, a classic, a bag full of marbles. There's 6 blue marbles, 8 red marbles, and then we're doing a sample of 5 marbles, okay, and we want to know the sample proportion of red marbles, something like that. Okay, and so that's where p hat would be 0 first of all, and then 1 out of 5, so 1 red out of 5, 2 red out of 5, 3 red out of 5, and so on all the way along, and then finding our sample proportions. And you're going to do that via binomial distribution, okay, like you've seen in the past. For large samples, however, okay, p hat will be a known value. Okay, so i.e. 40% of students, whatever, 40% of students, I don't know, whatever it is, okay, I like eating chocolate. Okay, then p hat is going to be 0.4. Okay, and we're going to use that again to be thinking about our so that'll become our probability, when we're doing our binomial distribution for this. Okay, so it's pretty straightforward, this part, okay, because we've seen it before, more or less, as binomial. Okay. We can then talk about the mean and standard deviation. Okay, so if we have a sample of size n from a large population, so we need to know it's a large population, then the expected value of p hat, or the mean, is just equal to p. Okay, and the standard deviation of p hat is equal to the square root of p times 1 minus p on n. Again, you're going to notice that this is the same as binomial distribution. Okay, slightly different here though. Okay, slightly different for this one. Okay, in sample stats, the standard deviation is called the standard error. Okay, one other little change that we've got there. So we're going to have a look at an example now, okay, where we've got we're told that 70% of 17-year-olds in Australia attend school. Okay, a sample of 20 students are selected. We want to find the probability of p hat equals p. So that means our sample statistic is equal to our population proportion. Okay, or our sample proportion equal to our population proportion. Okay, well that means, okay, that if we've got 70% of 17-year-olds, so we want to find the probability that 70% of our sample attend school. So that means that we end up with the probability, okay, that x equals 14, because if we do 0.7 times 20, we get 14. So we want to know that 14% of our kids, of our 20 kids actually attend school. Okay, so again, from there it's going to be just a binomial. So we're going to do 20 choose 14, okay, 0.7, okay, because that's our p-value that we're given, to the power of 14, 0.3 to the power of 6, and when we plug that into the calculator, we're going to get 0.1916. Okay, so the probability that our sample proportion is equal to our population proportion is 0.1916. Okay, the next one is we want the probability that the sample proportion lies within 1 standard deviation of the population proportion. Okay, so what we need to do is we need to use this standard deviation formula. Okay, so we want to find the probability, okay, that we're within 1 standard deviation, okay, less than p hat, okay, less than 1 standard deviation, okay, above. So within 1 standard deviation. Okay, we want to be looking at something like that. Okay, we don't know what our standard deviation is yet, so we're going to work that out. So our standard deviation here, we're using our our sampling error. Okay, is our standard error. Sorry. So we've got p, which is 0.7. Okay, times 1 minus 0.7 over n, which is our sample size of 20. Okay, so when we calculate that, we find that we get 0.1025. Okay, so we want to know that our sample proportion lies within this standard deviation of the population proportion. So what we're saying now is we want to find the probability. Okay, now our sample proportion is 0.7, so we want to go 0.7 minus this thing, 0.1025, and 0.7 plus 0.1025. Okay, because they're going to be our upper and lower bounds, if you like. So when we do this, we get 0.5975. Okay, is less than our sample proportion. Okay, and is less than, when we add that on, we get 0.8205. Okay, which, when we actually multiply these by our sample size of 20, okay, we find that this is 11.95. Okay, so we need to round that. So we're going to say that the probability that we're 12 less than, well, we can say x this time if we like, less than, if we do this one, we find that it's just over 16, so we round to 16. So I'm finding the probability that we're between 12 and 16. Okay, so to work that out, you're going to use your calculator. Okay, to do this, okay, and we're still going to be using our probability as our 0.7 in here. Okay, and so when we do that, we find that we are a probability of 0.7795. Okay, so we can need to use this standard deviation. Okay, actually find out what it is. Okay, to see what our, if you like, our sample proportion is, less our standard deviation or plus our standard deviation, or it could be less 2 lots of our standard deviation or plus 2 lots of our standard deviation. So we actually get it as a population proportion, and then we want to convert that to what it would be for our sample proportion, just by multiplying by our sample size, in this case our 20. Okay, and then again at that point is binomial. You know, for this one we definitely want to use our calculator because it could be 12, 13, 14, 15 or 16. What a pain. Okay, so we need to be making sure that we're all over how to use our calculator to find those ones. So look, hopefully that will help you out with some of the questions on this section.